Hello everyone, I hope you're all doing very well. For today's valued viewer requested question we've got here, I've accidentally taped over your name, but I'm sure you know who you are. Exterior aircraft lights. Can you explain external lights? What every light is for and how should they be used in specific situations? When I should use steady navigation lights, when flashing, when anti-collision, etc. What are the general rules of using external lights, especially in military aviation? So let's go and look at it in general and talk about it as we go. As ever, put together by our fabulous Ivan, and let's go through it. So, external lights in aviation. Planes are equipped with a variety of lights that are used for navigation, safety, and to improve visibility during flight or when taxiing on the ground. Virtually all aircraft types are fitted with external lights of some description. The type, purpose, and complexity of the lighting systems installed on the interior of a particular aircraft vary in accordance with its size, role, and normal flight environment. External lights, in general terms, serve one of three purposes. 1. To make the aircraft more visible to other aircraft. 2. To improve pilot visibility during critical phases of flight. Or 3. To provide illumination for some other specific purpose. Note that there is often an overlap in the utility of some of the external lights. As an example, landing lights greatly improve the pilot's ability to see the runway during takeoff and landing, but also enable the aircraft to be seen by ground personnel and by other airborne traffic. Let's try and explain the most common types of external lights. The external lights on aircraft fall into two general categories. The first is navigation lights or beacons that are always illuminated while the aircraft is in operation. A second type includes takeoff and landing lights that are used to improve visibility when the plane is close to or on the ground. So, navigation lights. All aircraft are equipped with a steady light near the leading edge of each wingtip. When facing forward from the perspective of the pilot, the light on the right wingtip is green, while that on the left is red. The different colours make it possible for an outside observer, such as the pilot of another aircraft, to determine which direction the plane is flying. These navigation lights are most useful at night when it is more difficult to tell the direction the plane is going without them. We move on to this guy here. We've got our aircraft here. On the left, we've got our red navigation light. On the right, our green, and on the rear, our white. So if we will look at it from the right-hand side and the plane was moving the direction of my cursor there, left to right, we would see that green there, that white there. We'd know the aircraft is flanking left to right, and vice versa. We'd know the aircraft here is flanking right to left, and the aircraft with green on the left and red on the right. Then we know the plane is incoming, and the general rule from our valued viewers is red on the right, dead in flight. And we've got aircraft outgoing here. We're going to see white to know that it's outgoing, and we're going to see red on the left and green on the right. Navigation or position lights. In addition to red and green lights, most planes are also fitted with other steady white navigation lights in various locations. Large airliners in particular will often have such lighting on the trailing edge of each wingtip. These lights are also sometimes placed along the trailing edge of the horizontal tail. Another popular location is at the very aft end of the fuselage or at the top of the vertical tail. One of these latter lights placed along the aircraft centerline is especially common on smaller airliners and commuter planes. Whatever the location, the purpose of the steady white lights is to improve the plane's visibility from behind the aircraft. And we can see here we've got a large airliner. We've got our green on the leading edge wingtip, red on the left leading edge wingtip, white on the trailing edge right wingtip and the trailing edge left wingtip, and at the rear of the tail facing rear. Next is anti-collision beacon lights. Two beacon lights are fitted to aircraft near the center of the fuselage. One is located on top of the fuselage and the other on the bottom. These lights are colored reddish orange and rotate to produce a flashing effect. The beacons are turned on just before the engines are started, and they remain active until the last engine is shut down. The beacons help to serve as a safety warning to ground personnel that the engines are operational. And you can see that guy up there, and you can see that kind of one under the belly. Next, we have strobe lights. High-intensity strobe lights that flash a white-coloured light are located on each wingtip. Most smaller planes are only equipped with one of these strobes near the leading edge, just behind a red or green navigation light. Larger airliners may be equipped with an additional strobe at the trailing edge as well. They are sometimes also used on the runway and during taxi to make the plane more conspicuous. They are the brightest lights on the aircraft and are used to signal that an aircraft is entering or approaching an active runway, or for visibility in dark, clear sky. They are sometimes turned off in cloud or fog, as they can further obscure the pilot's sight outside of the aircraft by reflecting off water particles. And we've got some examples here. Flashing there, flashing there, flashing there. Next is logo lights. These lights are not required but are common on most commercial aircraft. These lights are usually located on the surface of or at the tips of the horizontal stabilizer. The steady white lights are used to illuminate the company's logo painted on the vertical tail. While useful for advertising, the primary purposes of these lights is safety, since the bright lights help to make the plane more visible. And don't think this is just commercial. We've at least 2 planes in DCS have this, 2 military fighters. I think F-16 and Viggen stand to be corrected, at least those. Next, we've got wing lights. Many airliners feature lights along the route of the wing edge that can be used to illuminate the wing and engine pylons in flight. These lights may be used to make the plane more visible during takeoff and landing, or to inspect the wings for damage in flight. Pilots can also use the wing lights to inspect the wings and the slats for any ice accumulation that might build up when flying through clouds. They are often used during hours of darkness for aircraft pre-flight inspection and for illumination during engine start. Now, I don't know of any small military aircraft that has this. Does any of you guys know of any type of DCS aircraft that would have these wing lights? I've never seen them before, I don't think.
Not DCS ones.
Taxi lights. A bright white lamp is located on the nose landing gear strut of most planes. The light is typically turned on whenever the aircraft is in motion on the ground for greater visibility during taxi, takeoff and landing. So it lets you see where you're actually taxiing. Landing lights. Bright white landing lights are usually fitted to most planes for enhanced visibility during the landing approach. These lights can also be used to illuminate the runway at poorly lit airports. They are often required for night landings, but also commonly used during the day as well to make the plane more noticeable. While the usage of these lights is common, their location can vary from plane to plane. Landing lights may be located in the wing root, in the outboard wing, or somewhere along the forward fuselage. Some aircraft are equipped with multiple sets of landing lights in more than one of these locations. The 737, for example, has inboard landing lights located in the wing root, as well as outboard landing lights in the outer flap fairings. Runway turn-off lights. This is something I've just learned about. Are usually located in the leading edge of the wing root. These bright white lamps are intended to provide side and forward lighting during taxi and when turning off the runway. These lights are most useful at poorly lit airports, but still usually are unnecessary. The lights can also be used in flight if greater visibility is required. Ice detection probe light. Some aircraft are fitted with a visual ice detection probe, which is normally mounted along the windshield. In some installations, the probe is internally or externally lit to enable the pilots to see any ice accumulation occurring during the hours of darkness. The inspection light illuminates the wings and engines, allowing the flight crew and maintenance personnel to check for any ice buildup, snow, or damage when necessary. The lights also improve visibility of the plane. Searchlights, my favourite. Enforcement aircraft such as helicopters and search and rescue aircraft may be equipped with high intensity searchlights. Now, interestingly, you can have fighter aircraft. The Mirage 2000C, I believe, in DCS should have a searchlight that it can, shoot at aeroplanes, so it can illuminate their tail to see their tail number or their logo or whatever. We don't have it in DCS yet, but it's apparently something that we're supposed to have, so that's interesting. Formation lights. Some military aircraft have variable intensity lights installed on the upper surface of the wings to facilitate night formation flights. These lights may be in the visible or infrared spectrum. Formation lights are used so the aircraft can fly close in formation at night. They are typically luminescent strips positioned so that the aircraft can be in the desired position, i.e. fingertip formation, and have references fore, aft, up, down, near, far, similar to references as used for daytime formation flying. Something along the lines of keep the position light just below the formation light strip, under the cockpit and after the fuselage light strip, just touching the wing hardpoint, and you're in the right position. If the position light goes further below the strip, you're getting too high. If the hardpoint is sliding back into the aft light, you're getting too close, and so on. Obviously, these references are very specific to each individual aircraft type. As to why only military aircraft have them, how often have you seen or heard civil aircraft flying in formation at night? There are very, very few non-military reasons for formation flight, and essentially none that require it to be done at night. And of course, most of the planes in DCS have these. You see these lovely kind of turquoise type lights on most of these aircraft that I think look really cool. Now let's look into our viewer's question about the differences between a steady and flashing light and if the flashy ones follow a pattern. Civil aircraft have flashing lights based on manufacturer design preference. Aircraft like Boeing and Airbus have different patterns, though the double flash does identify the plane as an Airbus and a single flash is usually a Boeing. As to the pattern, there is no specification or a specific pattern that aircraft manufacturers need to follow. For an aircraft like an Airbus or other, wingtips may have a different bling pattern because the manufacturer wanted it that way. Military aircraft can often select the pattern that they want to use. This helps military pilots identify key tactical aircraft during night operations, such as the tanker flying around the carrier. It is definitely not coincidental if you notice a military aircraft with a unique flash pattern. Each aircraft role flashes differently. I'll use F-18s as an example because they are multi-role. An F-18 tanker might flash one way whereas an F-18 strike fighter might flash in a different way. Both same aircraft but different jobs, hence different patterns and less confusion or chatter in the air. There's no specification for a pattern of flashing and significant variation exists among different airlines and the military. There is a uniform requirement for position lights, steady red and green on the left and right wingtips, white on the tail, and an anti-collision light system which is one or more flashing lights which can be anywhere on the aircraft. US requirements are in 14 CFR 25.1401 and say that the systems must appear to flash between 40 and 100 times a minute. Areas where lights overlap can have as many as 180 flashes per minute. In general, lights flash for the same reason that hazard lights flash in a car, because flashing lights are easier to see than solid lights. This applies to a lot of things in aviation. Building lights, tower lights, aircraft lights all flash because it is easier to see a strobe in low visibility than a steady light. White strobes are also brighter and red strobes are less reactive to the eye, which is why cockpits use red light. All these combined help to make the strobes easier to see and identify. Red flashing lights, top and bottom of an aircraft, are turned on when the pilots are clear to start an engine. If you see those lights, you know there is an aircraft with running engines, so people on the ground should be careful. Flashing lights at the wing means that the aircraft is airborne or about to be. Pilots turn these lights on when they are on the runway. These lights stay put during the entire flight until the aircraft is off the runway after landing. Flashing light at wings are called strobes and are a form of anti-collision lights. It depends on aircraft model and role when they're turned on. Some aircraft have no red flashing lights. These aircraft generally turn on strobes before engine start. FAA requests the AIM manual for pilots to only turn strobes on just prior to takeoff and turn off immediately after landing, so the eyes of landing aircraft are not distracted or confused with the other runway lights, such as the REIL, runway end identifier lights. Tail light is for you to be seen from behind. The aircraft behind you knows that there is an aircraft in front of him. And that's all we've got here. Thank you very much for putting all the research together, Ivan.